Alright, this lesson is going to be on graphing rational functions and asymptotes. Alright, asymptotes they're an imaginary line or lines your graph gets close to but does not ever touch. There are vertical and horizontal asymptotes. So we'll look at vertical ones first. So we're going to use dashed lines to show the asymptotes. So they could be anywhere on the graph. So we could have it there, could have it there, could have it there. They're just vertical lines, and I'll show you what your graph looks like. But that's how we're going to represent the imaginary lines with these dashed lines here. And on the horizontal, then they're going to go horizontally. So it could be there, could be there, could be there, could be right on the x-axis, could be down here. So we're going to represent those. And same way at the vertical one. Your vertical asymptote, I should have said, can go right through your y-axis too. So let's say we have a vertical one. Let's say we have one right there, because you can have multiple ones. Usually it's going to be probably two. Could be more though, but most of the time it's going to be two for our reason. And let's say we had one over here, and maybe we had a horizontal asymptote that was going up this way. So our vertical asymptotes are in the red, and our horizontal is in the blue, and our graphs could look something like this. And it could be something like this, and maybe like this. There could be many different ways this could be, but those graphs, those lines I just drew in black, those are getting very, very close as they continue out to infinity and negative infinity and up the y-axis and down the y-axis. They are getting very, very close to those blue and red lines, but they never ever will touch them. So they're getting so close they look like they're touching, but they actually never will. Alright, so how do we decide how to find those? So we'll look at the horizontal asymptotes first. Look for the exponents, or the degrees, of the equations in the numerator and the denominator. If the exponents or the degrees are the same, excuse me, your horizontal asymptote is the coefficients. So we look at our equations in both the numerator and denominator, and they have to be in descending order. Well, they don't really have to be, but it does help so you can see what they are. So our highest degree is a 2 in the numerator, and it's also a 2 in the denominator. The 4 and the 8 don't look like they have one, but I really could put x to the 0 power for both of them. And that's not changing the equation because, and I'll show you down here, any number to the 0 power represents 1. So any number to the 0 power is 1, so really we didn't change that 4 at all, because 4 times x to the 0 power means 4 times 1, which is still 4. Same thing with the 8. So since the numerator and denominator, the highest degree is 2, and they are exactly the same, they have to be the same on there to find the horizontal on this one. Then we're going to look at the coefficients, which are right there, the 3 and the 5. So that is our horizontal asymptote. So if our degrees or exponents are exactly the same, we look at the numbers in front, the coefficients, the 3 and the 5. We go to 3/5 and draw a horizontal line right through 3/5. So let's say that's 1, that's 2, 3/5 is, I don't know, probably about right there. And we would just draw a dashed line there. That represents our imaginary line. So if we had graphed that equation, our graph, whatever it would come up very close to that line, the blue line, but would never ever touch it. Keep getting closer and closer and closer, but would never touch it. On the second example here, our coefficients our exponents are our degrees. We have 1s there. So if you don't say anything, you remember clear back in algebra, there's not an exponent number there showing, it represents a 1 there. So since they are exactly the same, got a 1 here and a 1 there, then we look at the coefficients. In the coefficients, since there doesn't look like there's a number there, there's always a 1 there. So our coefficients on these equations are 1. So I go to 1, and I would then draw a dashed line through there. That is my horizontal asymptote. So what if the degree in the top, in the numerator, is less than? Well, if the exponent degree of the numerator is less than the degree of the denominator, your horizontal asymptote is going to be 0, which means it's going to be right on the x-axis. So our degree on the top one, this first example, is a 1, and that is less than our 3. So since it is less than the denominator exponent of degree, then our line, our dashed line, our imaginary line, our asymptote, horizontal asymptote, will be right on the x-axis. Same way with this one here, it's like the second example. It doesn't look like there's a exponent there, but remember we could put x to the 0 power there, and we have a 1 up there, and 0 is less than 1. So since it is, our horizontal asymptote is going to be right on the x-axis. On our next one, if the exponent or degree of the numerator is greater than the denominator exponent or degree, then there is no asymptote, the horizontal asymptote. So you can see here we have a 3 and there's a 1 there. Since the 3 is larger than the 1, the horizontal asymptote is none. So you just write none. There is none at all. So if it's, sometimes you'll hear people say it's top heavy, meaning the numerator, or excuse me, the numerator exponent degree is larger than the denominator exponent, then it's top heavy, and the horizontal asymptote would be none. And now for finding the vertical asymptote. So here we have, we're not going to worry about the horizontal right now, so we don't care really what's in the numerator, because we're only going to concentrate on the denominator, because we're going to look at that, and the denominator always gives us our vertical asymptote. So don't worry about what's in the numerator, just look at what's in the denominator. So solve the equations or equation in the denominator. If the equation has not been factored, you will have to factor it first. So in the first one, we have 5 over x minus 2, and there's only one equation there, so we take the equation in the denominator, solve it. X minus 2 equals 0, x equals 2. So we go to 2 on our axis, or excuse me, on our graph, and draw a vertical line right through 2. So there's 1, there's 2. So then we just draw our imaginary line, which is our asymptote, vertical asymptote for that equation. And we don't worry about the graph right now, we'll talk about that later. Here's another example, 4 over x squared minus 9. So x squared minus 9 is a difference of squares, so it can be factored, which is x plus 3, x minus 3. And I've already factored it for you, and I have solved for each of the equations. So here I'm going to have two vertical asymptotes, one on negative 3. So it's going to go right through negative 3, and also one at 3. So in this equation, this function would give us two asymptotes, vertical asymptotes, and one goes through negative 3 and one goes through 3. Alright, here's an example, another example. So once again, this one is already, we're still going to find the vertical asymptotes, and this has already been factored for us. That's nice, it's done for us in the denominator. So you just take each equation and you solve for x in that. So I have a vertical asymptote at 2 and one at negative 3. So I draw my imaginary line right through there and right through there too. And right now we're just concentrating on vertical asymptotes, so we're not going to worry about what the horizontal was. So these are just examples for vertical. So that would be my vertical asymptotes for this equation. Alright, in our next one here, I have 5 over x squared minus 6x plus 8. So x squared minus 6x plus 8 has not been factored. So I do have to factor it, which is x minus 4, x minus 2, and after I factor it, I set them equal to 0 and solve for those two equations. So after I've done that, then I can see my vertical asymptotes will be at 4 and at, whoops, over here, 2. So it's going to be one right through there and one right through there. So those are my vertical asymptotes for this function. Once again, we're not going to worry about horizontal right now. We're just going to concentrate on the vertical so we can get examples from that. Alright, and our last one, I'm going to have you do this one. So we're going to find our horizontal and our vertical asymptote. So I'm going to let you go through this example and see what you come up with, your vertical and horizontal asymptotes, and then we will graph those on there. We'll work on looking at both of those, and I'll give you some more examples after we've gone through this one. So take your time, go back if you need to on these equations, or excuse me, these slides on finding the vertical and horizontal asymptotes, and they're really not that hard on there, so please take your time and review over them if you need to. Bam!